I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 25th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, real data for outdoor people, all the time, no hype.
Looking at significant wave heights for the South Pacific Ocean, we have a gale, yay, in the Southeast Pacific, generating 34-foot seas over a small area aimed northeast, and at California down into Central America and South America, but not really at Hawaii, and just starting to get organized. Other than that, a pretty calm pattern is in control. As usual, we'll start by looking at the jet stream. These winds up about 30,000 feet help support the formation of gales, and when they form, help direct their track. We're looking for a trough, a push in the jet to the north, just like that. Pretty classic trough right there. But keep in mind, the ice line's right at about 63 south, so it's just this little area from here northward that is available to support gale formation. What happens is the jet starts, when it's in this pattern, creates a clockwise flow aloft and down at the ocean surface. That's the hallmark of low pressure in the southern hemisphere. And low pressure, if it's deep enough, generates winds. Winds, if they're strong enough, generate seas. Seas, if they're high enough, as they radiate away from the fetch area, turn into swell. And of course, swell, when it hits your beach, turns into surf. So we have a favorable area for gale development right here. And we know there is some sort of a gale happening in that area because we saw seas in that area on the previous chart. Winds are about 130 knots. That's pretty good speed, pushing up to the northeast. In the correct quadrant of the gale, the left quadrant, the west quadrant, that's where you want the winds in the low pressure system right here to be blowing the hardest, pushing up towards, well, of course, our targets. All right, as we get into Sunday afternoon, the trough builds even more. Winds pick up more. That's favorable. Continuing off to the east as we get into Monday, and then things start settling down. The cutoff for the swell window for Southern California about 118, so 118 west. So even on Tuesday, there's still some energy in the swell window, and then the trough pretty much fades out. Behind it, a big ridge takes over. See the northern branch of the jet here, southern branch here. In between, massive high pressure. The ice line at 63 south, so the jet is pushing south of the ice line over Antarctica proper and building only stronger as we get into Thursday. Now notice a little bit of a trough is forecast over in this area on, we'll say, even as early as maybe late Wednesday, early Thursday, and then another trough as we get into Thursday night, right on the edge of the California swell window. Maybe something will happen there. The models were hinting at it a day or two ago. They backed off recently, but still, look at that. The trough continues even into Sunday as it slowly starts moving out of the California swell window. So something to monitor. All right, let's go take a look down at the surface. All right, so here we are, surface level pressure, surface level winds for 12Z on Sunday. Our gale with 45, almost 1 pixel of 50-knot winds there, aimed well off to the northeast, and the gale itself pushing off to the northeast. This is a good setup for probably some small swell. We get into Sunday night. The gale continues even into Monday morning. Tiny fetch area, but a broader area of, we'll call it 30 to 35 knot winds aimed well off to the north, building to 40 knots for a second there, and then fading out as we get into Tuesday and gone. As expected, right there, 1040 millibar high pressure sets up. The ice line right around here. Any fetch generated aimed south into Antarctica. Nothing expected there until we get into, again, Thursday. Remember, there was a trough forecast for the Southeast Pacific. 35 knot north winds, but kind of fading out. Not well organized. 1040 millibar high here. Quite strong. Weak low pressure off in this area. It was previously forecast stronger, so probably not a lot of swell production. We'll see. Saturday is a minor flare-up of fetch. We'll see what really happens. We're almost a week out. Maybe we'll get lucky. Maybe we won't. All right, let's go take a look at the wave models. Now we're going back in time. There is swell in the water, by the way, right now. Very small, little bit of a gale. It was southeast of New Zealand 9 days ago. It's rolled off even the hindcast models now. Had 30 2-foot seas, maybe aim northeast. That swell is hitting, nothing huge, should be peaking this afternoon, Sunday afternoon into Monday morning. We'll call it, I think it was 2 feet at 16 seconds this evening, and then 2 feet at 15 seconds tomorrow morning. So little waves for South California, North California, nothing great, maybe some chest high sets, that sort of thing. But it's better than nothing at all. All right, a week ago, Sunday the 18th, another gale formed off of New Zealand with 27-foot seas, but they were all aimed off to the southeast, building to almost 30 feet, still aimed. The fetch in there was pretty much aimed southeast, but then the gale redeveloped as we got into Monday with 30-foot seas. Again, this is all aimed off to the east, but a little bit of sideband swell should be expected up to 32.2 feet right in this area. So, and then 33 feet, something like that. And then Tuesday of last week, fading out, pushing out of the California swell window. Tiny swell. I mean, we're talking, because it's all aimed off to the east, sideband swell rating up to California, we're talking 1 foot at 16 seconds or something like that. All right, moving on. This past Thursday, there was supposed to be a pretty good gale under New Zealand. It looked great on the models 5 days before it formed, but by the time it actually got there, basically nothing happened. So we see nothing happening there, and now this is where we are right now. Let's go to the forecast model. And here we go. This morning, Sunday, 12Z, our fetch, not a small area, 30-foot seas. I mean, not a lot of production here, but a reasonable coverage and aimed well off to the north. That's the best thing this one had going for it. So swell arrival in roughly a week or so, early next week sometime. Again, nothing large, all confined to California, Mexico, down into Central and South America. Then the big high pressure sets up here. A little bit of fetch, maybe off to the east, but you can see just nothing really showing. We're almost a week out. And oops, we are a week out, and that's it. So this next system, in fact, will run this one right here. Looks like the best hope it's forming right now and tomorrow into maybe Tuesday. That's going to be our last significant swell producer, and even that's not significant, just rideable swell. And after that, things look pretty quiet. So then out of desperation, we go looking for wind swell. High pressure driving the scene right now. North winds 20-25 knots along the Cape Mendocino coast, north of pretty much from Point Arena northward, making for some small, junky wind swell with exposed north-facing breaks from North and Central California. East trade wind swell for the Hawaiian Islands today. Come Monday, pretty much not a whole lot of change, though the fetch fades even more off of North California. Tuesday, it's all but gone. Wind swell fades out for California, and pretty much the east wind swell starts fading out for the islands. Wednesday, no real change. Thursday, maybe a little bit better wind swell for east-facing shores of the Hawaiian Islands, and maybe not even enough to call it wind swell yet for California as we get into Friday. Little bit more fetch develops, nothing super strong, and then we're into Saturday next weekend. Okay, then finally maybe wind swell. We'll give it for exposed breaks, minimal, waist high sort of thing. Same thing for the Hawaiian Islands. And then Sunday, better fetch. Now, the models are suggesting a low, we won't call it a gale low, but a low up in the northern Gulf of Alaska. We don't believe that's going to happen. It's a bit early. August 15th is the typically the earliest we've ever seen any reasonable, by that we're talking shoulder high to head high, swell in the North Pacific from a legitimate gale in the North Pacific, but this year, we don't think we're going to be that lucky. All right, let's move on. Precipitation potential, and this is really not so much a precipitation forecast as it is a lightning forecast, but anyone that's on the John Muir Trail, Pacific Crest Trail, anything along here we're watching, there's been a lot of talk on the weather Twitter feeds and things like that about developing monsoon pattern for the southwest U.S. So that brings rain, that's good, but also so we're seeing some rain come Monday into the Sierra, into Monday afternoon. That's typically when they fire up, and when this happens, you also typically get lightning and the potential for fire. Tuesday, it backs off a little bit. Wednesday, another maybe little burst, even into Thursday, Friday, and then Saturday and Sunday, 5 p.m. So a pretty consistent wet pattern for the Sierra through the reasonable forecast. Then after that, it looks like the monsoon starts pushing off to the east and out of the picture. So if you're on the trail, probably for the next week, expect afternoon rain. And if you're monitoring fire in the Sierra, potential for lightning is likely. And a quick look at the snow forecast dashboard. We're not looking at snow, but what we're looking at is temperature levels here. The red is liquid precipitation. We're looking for any dip in this to suggest maybe cool air coming. It's still early. It's late July. Again, we wouldn't expect to see anything showing any change in this brick wall of red until probably sometime in the mid-September timeframe, but we're taking a look just the same. All right, let's go take a look long term. What's going on with the Madden-Julian Oscillation and, of course, the El Nino Southern Oscillation. The MJO is that periodic weather pattern. There's an active phase and an inactive phase. It's constantly rotating around the planet. On one half of the planet is the active phase. On the other half, the inactive phase. The active phase is what we want because it is essentially low pressure, and it moves west to east around the planet on the equator. When that low pressure center moves over, or it's more of a bias, we'll call it, over the Pacific, it adds energy to the jet stream. It can also dampen trade winds wherever it is located on the equator. When the trade winds slack off, it can even reverse trade winds. That can create a thing called a Kelvin wave if it's over the West Pacific. Kelvin wave is warm water pushing from west to east, and if you have successive Kelvin waves, that can eventually usher in El Nino. We don't think that's going to happen, but we're always looking for it. So let's get into that portion of the presentation. So the first part of the long-term forecast here is all about the MJO. We're on the hunt for the active phase of the MJO, and if not that, at least trying to figure out when the inactive phase is going to exit the Pacific. So we start by trying to figure out what's going on MJO-wise. We're looking at winds, these arrows. This is the East Pacific here. This is the West Pacific here. That's New Guinea. This is the equator right here. The arrows show the wind 5-day average wind direction. The longer the arrow, the stronger. So pretty strong east trades over the East Pacific, pretty strong east trades over the Central Pacific, and moderately strong trades over the Kelvin wave generation area from the far West Pacific, 135 east to about 170 west here, and 5 degrees north and south of the equator, just right on the equator. That's the area we're most interested in for feeding energy to the jet and creating Kelvin waves. But it's not the actual wind speeds that matter. It's the difference from normal for this time of year. So they call it anomalies. There are charts and historical records on what is standard wind speeds for every area of the planet, and then you compare what's actually going on to those to see, well, are they stronger or weaker on average than normal? So in the East Pacific, you see really no arrows going east or west, so pretty much normal. Same deal over the Central Pacific. In the Kelvin wave generation area, winds are a little bit stronger out of the east than normal, so that would suggest, so it's enhanced trades versus reduced trades or no trades. So that would probably suggest the inactive phase of the MJO. So what have winds been doing the past 5 days? So we have a panel here, a panel for each day. South America there, Central America, Mexico there. 0, that's the equator right there. Okay, there's New Guinea, Australia, Philippines. Kelvin wave generation area, roughly this area right in here. The blues are easterly anomalies, the reds westerly anomalies, and it's just right in this box here. Mainly easterly anomalies, so that would be on the, that's the 19th of July. 20th of July, kind of a neutral pattern. 21st of July, kind of a neutral pattern. Same thing on the 22nd. 23rd, a little bit stronger easterly anomalies. So neither a clearly defined active or inactive phase of the MJO. So what's the forecast for the next week? All right, so this is sort of the same deal. The blues are easterly anomalies, the reds are westerly anomalies. The westerly anomalies are what we're looking for. That's the indicator of reduced trade winds and the active phase of the MJO. But where are we? This is the whole planet on one chart. So the date line runs right up the middle there. Okay, we know the Kelvin wave to the far west Pacific starts about 135 east, so right around here. Okay, and this is the forecast down here below this line. This is what's been happening prior to that, 3 weeks prior or so. All right, so looking right here, you can see lots of easterly and the Kelvin wave generation area ends at 170 west, so right about here. So between there and there is our focus. We see piles of easterly anomalies, the inactive phase of the MJO, pretty much the whole month of July. And now moving into the latter part of July, the next week, easterly anomalies trying to slide out of the Kelvin wave generation area, but then rebuilding, back building a little bit right on the date line, maybe 4 days from now, something like that. Westerly anomalies today in the Kelvin wave generation area, but getting progressively weaker. In general, this just kind of looks like a pretty mixed pattern. At best, an active phase, trying to make it across the Kelvin wave generation area, but dying maybe 4 days from now. That's just our best guess. We'll know in a minute here. We're going to take a look at some other charts. All right, outgoing long wave radiation, another component of the MJO. We said the MJO is like low pressure. Okay, with low pressure, you can have changes in direction of wind from east to west. You can also get clouds, and that's what this is all about. This model's a cloud cover projection. The blues are negative outgoing long wave radiation anomalies. Is that a head twister? Basically, it's fancy words for cloud cover. There's more clouds, less sunlight reflecting off the ocean surface. Oh, and where are we? Equator's right there. South America, Central America, Hawaii, New Guinea, the Philippines, Kelvin wave generation area right there. So accordingly to this, today, the active phase, week 1, is over the Kelvin wave generation area today, dying out some 5 days from now, completely gone 10 days from now, with the inactive phase, positive anomalies, more sunlight reflectivity off the ocean surface, clear skies and high pressure, so the inactive phase may be setting up. That per the statistic model. The dynamic model, pretty much saying the exact same thing. Yesterday when we were working on the forecast, this suggested that the active phase was going to last longer, but now just looking at that, the two models are pretty much in agreement. Phase diagram charts, okay, so this is the same deal. This is the statistic model, this is the dynamic model, but a different view of the active and inactive phase, all right? The MJO moves around the equator from west to east, from the Indian Ocean to the Maritime Continent, over the West Pacific, East Pacific, under the United States, across the Atlantic, over North Africa, back to the Indian Ocean. Where the heavy dot is, right there, is where the active phase is. The further it is away from the circle, the stronger it is. So at best, modest active phase of the MJO over the West Pacific today. 2 weeks from now, 3 different potential tracks, but all of them have it pretty much over North Africa or maybe the far East Atlantic, and exceedingly weak. Per the statistic model, dynamic model, squibbling around, but pretty much saying the exact same thing. So the models are in sync. The 40-day upper level model, all right? So this is showing, again, the potential for either dryness or wetness, all right? Wetness associated with the active phase, dryness with the inactive phase. 8 different panels, 40 days. South America there, Central America there. 0 is the equator, all right? New Guinea right there. And let's see, Philippines right there, Kelvin wave generation area, in generally that area right there. All right, so that suggests, and greens, wetness, active phase over the West Pacific Kelvin wave generation area, moving off to the east. You can see how it moves across the Pacific, pretty much out of the Pacific by August 24th, and a pretty strong inactive phase forecast taking over, at least in the upper atmosphere, starting early August the 9th, continuing across the Pacific through the end of the model run, so early September. So whatever surf we're going to get is probably being fed by the active phase right now, and then it looks like August for the most part is going to be a bust. The CFS model, this goes out a month, okay? Again, the whole plan on one chart. East-west component of the winds, east anomalies, the inactive phase are the blues. The reds are westerly anomalies, the active phase of the MJO. And someone made a comment along the lines of, well, then if the act, this was on, I think it was last week's video or maybe the week before, tropical development, then shouldn't tropical development be enhanced by the active phase of the MJO? And the answer is absolutely yes. Now, it's not 100% correlation. These are tropical systems, and this is all past, oops, let me scroll it up here. This is all past performance. But here, the solid contour is the active phase of the MJO. Notice tropical systems forming around, oh, and another little component over here, tropical systems forming around that. But here's an inactive phase, and we've got a tropical system there. Then there's no phase, and you get tropical systems. But in general, and this is only confirmed ones, there's no forecast, but you see building active phase for the past week and tropical systems around that. So the answer is yes. All right, so what's going to happen? Well, here we are, July 24th. The solid contour is the active phase of the MJO. The date line runs right up the middle here, West Pacific right about there. So the active phase moving into the West Pacific today, forecast to traverse through the Kelvin wave generation area till about for the next 2 weeks, and then out of the Kelvin wave generation area, still in the Pacific, but it's in this area where, one, you get Kelvin waves, and two, you feed energy to the jet stream. So that's why we're most interested in it. Then you see a little fragment of the inactive phase building, not even making it into the Pacific, but then easterly anomalies start showing up. So one can assume it actually is to traverse the Kelvin wave generation area starting about August 7th, and then probably through the end of the month. And then our favorite, the 3-month CFS model. We don't believe a model a week out, much less 3 months out, but one of our readers did suggest in a comment that believing even this model out as far as it goes is foolhardy. You look at the forecast projections, you make a little note of it, and then when that date comes, you see what's actually happening, and then you get a sense of how accurate a model is or is not. A projection is not reality. A storm forecast 2 weeks from now or 2 months from now is not meaning that it's going to happen. It's at best a limited possibility until it actually forms. Nothing is real until the winds are blowing on the ocean surface. Other than that, it's all a figment in the imagination of some computer somewhere. Sometimes pretty good, sometimes pretty accurate, but sometimes pretty far off. So take everything with a grain of salt. All right, that said, we're looking at a model that goes out 3 months. All right, this is, again, the whole plan on one chart. Date line runs right up the middle here. Kelvin wave generation area starts here and runs to about here, 170 west. Okay, this is past performance in the bottom. You get a sense of sort of this mixed pattern, neither active or inactive phase. But then you look up, and we're going to scroll up now here. There you go. You look forward, and you see this big patch of blue in the Kelvin wave generation area, and it goes on through the end of October. This smells very much, and blues are easterly anomalies. This smells very much like the return of La Nina. It's been forecast. So let's overlay the MJO, see what's going on here. All right, so the solid red contour is the active phase of the MJO, moving from west to east. You can see it's supposed to be traversing the Kelvin wave generation area. Date line somewhere. And we could scroll down here again. Date line's roughly right about there. So, and the yellows are westerly anomalies. So this suggests, okay, a decent chance for storm development through about, we'll say August 5th or 6th. Then after that, inactive phase comes in. Easterly anomalies for a bit until we get into the end of August. And then a much broader active phase of the MJO sets up, making it the whole way across the Pacific, but notice the westerly anomalies associated with it make it to about 170 east. Okay, that's almost to the date line. And then try to get over the date line, but they just get completely blocked, and we'll talk about that in a minute. So, but still, if there's a shot for storm development in September, we got the next week or so, and then September has a pretty good target on it. After that, things fall apart, and after that, who knows? We don't believe the model anyway. But what's driving these east anomalies? The return of La Nina. Well, so then there is another pressure pattern. They call it a bias pattern, or the low pass filter. And we interpret it as these dotted lines. This is like a high pressure bias over the Pacific. The solid line is a low pressure bias. Now it is over, we'll take a look down here, 120 east, that's the maritime continent. That's like Bali, something like that. Okay, it was forecast to push into the Pacific, but now you see come August 18th, the low pressure bias is to break up and totally retrograde back over the Indian Ocean maritime continent thing. The high pressure bias, which last winter was 1, 2, 3, 4 contours, pretty strong high pressure, it's retreated for the moment, but it's supposed to make a big comeback come late August. Actually, I thought it was going to be earlier than that, so this model's now sort of saying, well, maybe not. And then building to two contours, but even that is backed up. Last week, it was sooner and stronger than that. So there's some uncertainty as to how strong this, we'll call it the second resurgence of La Nina, is going to be. And you'll see some more about this as we go deeper into the presentation. So enough of the MJO now. Let's get into the El Nino La Nina thing. We already know, I mean, there's no surprise here. We're expecting La Nina's return. What's going on in the ocean? Is the ocean sensing any of this? All right, this is the East Pacific here. This is the West Pacific. We're not looking at the ocean surface. We're only on the equator, the whole way across the equator, from the West Pacific to the East Pacific, only 2 degrees north and south of the equator, a little thin band. All right, but that's where the TAO buoys are. These are the anchor lines on those buoys. The X's are sensors on the anchor lines. The sensors collect temperature data at different depths in the ocean. It's then all sent to a central processing facility. A model is run against it to fill in the gaps. And what do we have? The 29 degrees centigrade isotherm, that's pretty warm water, is at, what is that, about 173 east? I think that's what it was last week, pretty close. The 28 degree isotherm is steadily backtracking. It had been about 160, then at 170, 168. Now it's almost at 170 west, so it's backtracking. The 24 degree isotherm right here, that had been pushing the whole way into Ecuador. Now it's back to 115 west. What's that mean? It suggests that trades are stronger than normal. There is the active phases of the MJO are probably weaker than normal right now, with less west anomalies, not pushing this warm water off to the east. But let's go look at anomalies. Differences from normal for this time of year. All right, this is a significant downgrade, we'll say, from last week, because there was 0 to 1 degree above normal anomalies going the whole way across the Pacific into Ecuador. Now all of a sudden, this model / real data is suggesting warm water 1 degree above normal hold up in the West Pacific, rapidly breaking up over the Central Pacific and even in the East Pacific. But worse than that, -3 degrees centigrade anomalies are building down at depth to at about 150 meters down and pushing up to the east. So instead of a warm water Kelvin wave, it looks like a cold water Kelvin wave. The what do they call that? The upwelling phase, I think, of the Kelvin wave cycle is starting to set up, but what that means is cold water is going to start taking over the equator if this makes it to the surface, which it probably will with no real Kelvin wave generation potential forecast. Let's take a look at another model here. Now, it's even worse. This model was marginally better last week, but now, as of the 17th, but this actually updates every day, by the way. They do a major update every 5 days, but you can see perceptible differences in this data from day to day. Clearly, cold water moving in, taking over. The warm water regime that was filling all this 2 or 3 weeks ago is almost completely gone now. Not good. Sea level anomalies, so this isn't temperature data. But let's orient first. Chile, Ecuador, the Galapagos, Central America, Mexico, Baja, Hawaii, there's your equator, there's your date line there, New Guinea there, all right? These are not temperatures, -5, -10. This is the height of the ocean in centimeters. So there's a depression on the ocean surface. If you strip away all the waves, wind waves, tides, the sphere of the ocean surface is lower than normal here. Why would that be? Two reasons. One, cold water at depth contracts, creates a divot on the ocean surface. Stronger than normal east anomalies take water here, scoop it out, and push it to the west, leaving a indentation here. In either case, and you see negative anomalies along Chile, negative anomalies now building along Central America, off of Central America, though really we only care 5 degrees north and south of the equator. All this is starting to smell like we're going to get that below normal triangle starting to form here, which is the hallmark of La Nina. Stronger than normal high pressure here, and down here in the southern hemisphere. They interact on the equator. They start increasing trades here. They then eliminate the Kelvin wave flow. You get a lot of upwelling in this area, colder than normal temperatures. Cold temperatures eliminate evaporation. Elimination of evaporation builds in more high pressure, and that is the La Nina pattern. And if you have high pressure and dry air down in here, the same thing. It builds the high pressure up into the Gulf of Alaska. It pushes the jet stream further north, so instead of pushing into California in the winter months, pushes into the Pacific Northwest or up into British Columbia, and we're high and dry without water. And that is very much what La Nina is all about. A little historical perspective. West Pacific here, East Pacific here, ocean, upper ocean heat anomalies, temperature basically, but differences from normal. Okay, and that's the upper 300 meters of the ocean. You can see back August 2020, warm water in the west, La Nina, cold temperatures in the East Pacific taking over, peaking around the Halloween time frame. And then we got into March of this year, and all of a sudden, boom, we got a good strong active phase of the MJO. It tapped this warm water, pushed warm water off to the east in the form of a Kelvin wave, 1 Kelvin wave. A second Kelvin wave, a third Kelvin wave. But what that did is there was no warm water left anymore. The system fell apart, and then all of a sudden the emergence of cold water is redeveloping in July. Now that's better. The year before, and you can't see it here, but it was in April. Now we're not happening to July. The later it starts, the weaker it eventually will be. The strong El Niños that you have and super strong La Niñas, you can see signs of them in February and March typically. Okay, we're not getting any real momentum in this La Nina till almost the end of July. So how bad will it be? Well, at this point, any decrease in rainfall for California is a big deal. But at least it's not going to be we don't think it's going to be a super strong La Nina this winter. Upper ocean heat anomalies, same sort of chart, but in a different presentation. This is over time down at the bottom, and this is just from the date line to a point south of Mexico, somewhere 100 west. Okay, temperatures last August, September, October, November, colder than normal. You can see here, what's this down to? Like 1.4 degrees centigrade, so that's 2.5 degrees Fahrenheit below normal over the whole East Pacific. And then we got into March. Remember that transition time frame? Somewhere around February, March. Boom, we started warming up. We go, hey, maybe we're going to be okay. But now here we go back into the hole. A double dip La Nina is not unusual. We were being optimistic. That was our bad a couple months ago. We said, hey, maybe we'll squeak out of here without a double dip La Nina. But now it looks pretty apparent. All right, let's go take a look at the ocean surface now. What's going on? South America there. Chile, Peru, Ecuador right there. There's the Galapagos, Central America, Mexico, Baja, Hawaii, the equator right there. All right, we did see warming actually off of Peru, but now notice this blue is starting to show up. The extent of the warming is fading off of Peru. They're still warming off of Ecuador to the Galapagos and a little bit east of there, and then up into Central America. But We know that sea surface heights are fading here, so that suggests at depth there is cold water building, and we expect to see a lot of this erased over the coming weeks. We already see cold water starting to show up here along the equator from about 110 west, so off of, let's say, south of Cabo San Lucas, the whole way out to the dateline. There is warm water here, but we suspect that is remnant warm water from the erupting Kelvin waves. With trades increasing, that will be eliminated in short order. Sea surface temperature trend for the past week, and a week is not really much of a trend, but you see the blue, and it's just on the equator that we're interested in, 5 degrees north and south of the equator. Cooling, little pockets of warming, but kind of a mixed bag. But in general, this cooling, it started last week or even the week before that. It looks like it's going to continue for a while. Otherwise, a pretty neutral pattern in control, so the bias is towards cooling. And then the overview pattern, again, doesn't look too bad right now. I mean, it honestly doesn't. This isn't bad. In July, to see this, you go, okay, it looks like kind of a neutral year, which is exactly what it is. But it's the models we're keying off of, those 3-month models, those 2-month models, and you see the cold water. So that's the cold water building under the equator is not a model. It's confirmed data. There's hard sensors that see it there. Yeah, you're using a model to fill in the gaps. But then you got the satellite sea surface height measurements, the sphere of the ocean measurements. They're all saying it's negative here. So that pretty much suggests there is a cold water Kelvin wave, if you will, moving into this area, getting ready to erupt. And when it does, all this is going to be wiped clean in a second. Sea surface temperature index for the Nino 1.2 region. This is that area just right there along Ecuador and the Galapagos. Water temperatures today, pretty much dead neutral. 33 thousandths of a degree below normal. 0 for all practical purposes. And they've been hovering around neutral since July 13th. But prior to that, they were all cold. So we're going to eke out, what? 1, 2. I'm sorry, that was June 13th. So 1, 2, 3, 4, 5, 6 weeks of normal temperatures before we crash again. Probably, that's our guess. The official El Nino monitoring region, this is on the equator, 5 degrees north and south, from the point south of California out to the dateline. Temperatures have been on a steadily increasing roll into about, let's say the 4th of July. And then they've been on a steady, slow decrease. Other than today. Today, we're 8 thousandths of a degree above normal. All right, so basically neutral, and we think maybe we'll hold there for a little bit, but we suspect the pressure is going to be downward. So what does the atmosphere think is going on? We look at, there's one index we have, the Southern Oscillation Index, difference in pressure between Darwin, Australia, which is generally the Indian Ocean, and Tahiti, which is generally the West Pacific, we'll say. Pretty close to the equator, too. Okay? When pressure is lower over Tahiti, then we're at least in the active phase of the MJO. Remember, we say the MJO, when in the active state, is sort of like a low-pressure ball. When the index is positive, then that means high pressure over Tahiti, the inactive phase of the MJO. All right, so today's daily contribution, here's the actual, the pressure in millibars, 1,016.49 over Tahiti, 1,012.95 over Darwin. Daily contribution, 15.94, so above normal, meaning high pressure over Tahiti. And you just scan down here. I mean, we were up at 37.86, so what was that, about a week ago? And you can just see nary a negative reading to be found, suggesting at least the inactive phase of the MJO. But we'll take do a 30-day average. It takes the noise out of here. Today we're at plus 1503. Okay, but look at this, too. It has been steadily rising from just below normal a month ago up to 15. At this, I think this guy at its peak was at plus 19 at the peak of La Nina last year. So that gives you a frame of reference. The 90-day average, we call this the El Nino La Nina indicator, plus 6.47, but it has too been steadily rising. This is for sure a lagging indicator, but this got up to, I think, plus 15 at the peak of La Nina, but it's a 90-day average. So 3 months from now, so what are we, July to August, September, October, somewhere in October, wouldn't be surprised to see this guy up in like the 12 range or 10 range or something along those lines. Let's look at the graph. The 30-day average, we're using that because it's a little bit more immediate. There's a 30-day lag. Back in 2019, negative numbers. You can see the active phase of the MJO, low pressure, pushing the index negative. The inactive phase pushing it upward. So this was sort of like a weak El Nino here in 2019. When the inactive phases are stronger than the active phases, all of a sudden the index starts rising. We were at, this says 20 or 21 in January, February of 2021, the peak of La Nina. Then we started falling this summer. But look at this. This is a long-running, massive, inactive phase of the MJO, sending the SOI well into the positive range at about 15 or plus 15 or 16. All right, so what is the forecast for temperatures in the Nino 3.4 region, the official El Nino monitoring region? This is sea surface temperature anomalies, differences from normal for this time of year. You can see back in 2020, temperatures were below normal. This was our La Nina down at about 1.25 of a degree below normal. Then as we got into spring of this year, we hit normal. And we're still, according to this, maybe 15 hundredths of a degree below normal. But this forecast, uncorrected data, suggests us going to about 0.9 of a degree or so, maybe 0.85 below normal from October into January, and then returning to normal. The PDF corrected says, okay, maybe more like 0.75 of a degree below normal. Even that might be a little bit much. Half a degree below normal for 5 consecutive months is the La Nina threshold. So we're going to be below that, but duration-wise, just barely for 5 consecutive months. But that'll get us effectively still cold enough water so that we'll not have a particularly productive long winter and fall pattern is our guess. All right, so for right now, little swells in the water, nothing huge, but it is rideable. Another swell, really tiny one forecast after that. Another gale is developing, which could provide us for some surf. Oh, when is that? Not this next week, but the week after that for a little bit. And after that, things look like they're getting pretty quiet. We'll keep our eyes. There's another gale maybe forecast in the far southeast Pacific. But after that, it looks like high pressure taking control. Wind swell will be the primary source of swell as we get into at least mid-August or so. Inactive phase of the MJOs forecast after that for a bit. And the next opportunity isn't until September. Beyond that, looks like La Nina's revenge is developing. I mean, this is not a big surprise. We've seen it on the charts for months now. So it looks like it'll happen. Maybe not as bad as the first go around, but we need water badly in California. We'll take anything we can get. The plus side is maybe if things work out, you get the high pressure system set over the Pacific. If it moves to the west, sort of more out to the dateline, then you get backdoor troughs that the high pressure, the storms move over the top of the high pressure ridge and then fall down the Pacific Northwest coast into California. Now those typically are drier, but you get colder air with it. So you get a good amount of at least quality dry powder snow, good for skiing. So we're kind of hoping maybe that's the case, but that's purely a reach. It's July, making a forecast for January, something's a fool's errand. But right now, for sure, it looks like some flavor of La Nina is coming. NOAA's pretty much saying it. All the major outlets are suggesting it. So, no surprise there. All right, if you enjoyed the video, give us a thumbs up. We'd appreciate it. If you have any questions and concerns, write it down. Comment. We'll reply. We try to reply pretty quickly in a day or so, something like that. If you have not subscribed, please subscribe. If not, go to stormsurf.com. The link to the forecast will be posted on the top of every page of the site after we get the video up, and you can watch it that way. And other than that, we'll be doing this again next week. Same time, same channel, and on a new computer. It is here. Hooray. Thanks, Digital Storm, for sending the new machine. It's a beast. It's big and it's powerful, and hopefully it will be quite stable. So that's it for this week. See you next week. Go get some surf and be safe. Bye.